All right, guys, welcome back to another lesson on writing linear equations. Before we get into our new lesson, I'm going to go through and review a little bit, and this will tie into what we did on the last lesson, as well as some stuff we've been looking at throughout the beginning parts of this chapter on linear equations as well. So if you look here, this one says use the graph to write the equation of the line and answer the questions. So question number one, write the equation in slope-intercept form y equals mx plus b. If you remember on the last lesson, if you don't, you may want to go back and watch it again. We talked about finding the m and the b, finding the slope, that's the m, and the y-intercept. So if you look at this line up here, notice I have right here is the point where the graph crosses the y-axis. That would be 0, 1, 2, 3, 4, 5, 6. So 0, 6 would be my y-intercept. That means my b value, my y-intercept here, my b given amount, as we talked about on the graph, is 6. Then my slope goes down across through this way, so I know my slope is going to be negative, but I also know that right here is another point that it touches. And remember, you have to have 2 points to be able to find the slope. Then you can just count. Or you can actually use this point here if you wanted to, the point 5, 3, right 5 and up 3, if you wanted to just find the slope using your slope formula. It really doesn't matter. So question number 2 over here, or 3, excuse me, is going to be find the slope. So you could use the point 0, 6 and 5, 3 to actually find the slope using your formula, y2 minus y1 over x2 minus x1, and you get negative 3 over 5, or negative 3/5 as a fraction there. Remember, you can use your calculator to help you if you need to find your fraction answer there. But that's my slope. That's my m. So my m is negative 3/5, and my b is 6. You could also just look at the equation and find the slope if you wanted to by counting down 1, down 2, down 3, over 1, 2, 3, 4, 5, down 3, over 5. Negative 3/5 is my slope. So that's my m, and that's my b. So what would my equation be? Y equals negative 3/5 x plus 6. mx plus b. M is my slope, b is my y-intercept. So if I can find my slope and I can find my y-intercept, then I can write the equation of my line. So then the final question here that we haven't done yet, find the x-intercept and the y-intercept. Well, we already found the y-intercept is 0, 6, so you could go ahead and write that one down if you want to, because you already have it. Or you could actually go through the process of finding the y-intercept by letting the x be 0, plug in 0 for x into our equation, negative 3/5 times 0 plus 6, but you're still going to get 6, because 3/5 times 0 is nothing. To find the x-intercept, though, you are going to have to do a little bit of work here on this guy. Or you're going to have to make sure it's a really pretty graph that you can count. My suggestion is, unless you know for sure it crosses through a point, you might want to be careful with that. But this one's not too bad, so you could actually look and find your x-intercept over here. It's just a little bit off on this graph. That's why I would probably plug in 0 for y. Meaning, you plug in 0 for y into my function, negative 3/5 x plus 6, and then we solve this for x. First, we would subtract 6 from both sides. That would be negative 6 over here. Then we would divide by negative 3/5, or you could multiply by the reciprocal, which would be negative 5/3. If you multiply by negative 5/3 on both sides, wow, that's a pretty 3, isn't it? Multiply by negative 5/3, you'll get it to cancel out, and it will end up being positive 10 is your x value, or 10, 0 would be your x-intercept. So as we are learning, on these problems, when we talk about linear equations, there's several different ways that we can find the answers that we're looking for with all of these parts of the linear equation, whether it be the intercepts, the slope, or the actual equation itself. So last time in class, we talked about, and I should say on the last lesson we talked about finding the m, finding the b, finding the slope, finding the y-intercept, and plugging it into that format, mx plus b. We're going to use the same concept today of finding the equation, but this time we are not going to be given everything. We are not going to be given the m and the b. We're going to be given the slope, which is the m, and another random point on the line, meaning it's not the b value. It's not the y-intercept that you are given. So basically, right here, this is kind of the objective of the lesson here. In this lesson, what we're going to learn is to write an equation of a line when we are given its slope and any point on the line. So we're going to dive right in. We're going to take a look at an example here. You may want to pause it if you want to write down the question. We're going to write an equation of the line that passes through the point 6, -3, and has a slope of -2. So we have m because we have the slope. We have the slope is -2. But we do not have the b value. We are not given the y-intercept. Remember, the b is the same thing as the y-intercept we just talked about on that graph we did just a few minutes ago. We don't have the y-intercept. And the reason I know that is because this other point that I am given has an x value and a y value, but it doesn't have a 0 for x. So it's no way possible that it's the y-intercept where the graph touches the y-axis, because the y-intercept is always going to have 0 for the x value. It's a point that's over here somewhere. 6, -3 is over here somewhere, so it's not on the y-axis. So that is not my y-intercept. So I have m, but I don't have b. But I do have an x value and a y value from a point, x1 and y1, if you will. We don't have another x value and another y value because we already have the slope. We don't need 2 points because we already have the slope. But what I can do is I can use this slope and this point to find my equation. Here's how we're going to do it. We're going to use our same y equals mx plus b that we did before. But this time I don't have the m and the b. I have m, which is -2. So I'm going to plug in a -2 right there where the m is. I have an x value and a y value from this point. I have -3 is a y value and 6 is an x value. But I do not have b. So I'm going to show you again what I did there. I know that -3 is the y value from the point, so I plugged it in for y. I know that 6 is the x value from the point, so I plugged it in for x. And now I have an equation that has a setup in which I can find the b value. What do you mean, Mr. Harrison? Well, look right here. You have -3 equals -2 times 6. Well, if you can't do that in your head, use your calculator, but -2 times 6 would be -12 plus b. Meaning, if I can solve this equation and get b by itself, I can get my answer for b. I can add 12 to this side, add 12 to this side, and my b value, because this cancels out, equals -3 plus 12 is 9. So now I know that b is 9, my m was -2, And so now I can actually write my equation, negative 2x plus 9. Notice my final answer is an equation because that's what I was asked to find. I was asked to write an equation of the line. I wasn't asked just to find the b value. I wasn't asked just to find the slope. I was asked to find the whole entire equation, which means I needed the m and the b. And so what I did was I used my m that was given to me, and then I used that other point, which is not the b value, to plug in and find the b. And so that's the essential idea behind what we're doing today, is finding the equation when we are given less information than what we were given last class. Last class, we were given the m and we were given the b, and we just took them and we plugged them into the right spots. Now we have to take and find one of those, sometimes both of them, and we'll get to those questions a little bit later. So let's take a look at another example. Oh, sorry, I do have the steps here. If you would like, you can actually use these steps here. Finding the y-intercept first by substituting the slope and the coordinates from the point xy into the slope-intercept form, and then solving for b, and then writing the equation of the line. So if you want to write down these steps, you need to pause it because I'm not going to sit here on these steps long enough for you to write them. So pause it and write the steps if you want to. So let's do another example. So something you need to remember, is something we talked about earlier in the chapters when we talked about slope, is that if you have two lines that are parallel, they have to have the same slope. So this question says, write an equation of the line that is parallel to the line y equals 2/3 x minus 2 and passes through the point negative 2, 1. Now what is important to understand right here is that they are giving me, or I'm being given, a line y equals 2/3 x minus 2. Remember that one would have a y-intercept of negative 2, and then it would be up 2 over 3 for my slope. So it basically would be a line that's going up through here like this. They are telling me that I'm trying to find the equation not of this line. I have the equation of that line. What I'm trying to find is the equation of a line that is parallel to that line and passes through the point negative 2, 1. So there's a point over here that a line passes through, and it's parallel to this one. So I know a point that it passes through, negative 2, 1, and I know that it's parallel to this one. What did I just tell you about parallel lines? Parallel lines always have the same slope. So whenever you know that it's parallel to this one, it would have to have the same slope. So what is the slope of that line? Remember, it's mx plus b, so 2/3 would be the slope. But here again is where you need to be careful. You don't know the b value right here. You don't know the y-intercept. You know another random point, negative 2, 1. You do not know the b. I know you see a b value right here, but remember, this is the other line. This is the line that we have right here, but we're looking for the line that is parallel to this line, not the same as this line. So do not use this b value right here. The slope is the same, but the b value is not the same. So we have a slope and we have a point. And so now what I want you to do is I want you to go back over here, just like we did here. We plugged in our slope. We plugged in our x and y value from the point, and we found the b. So I'm going to go back over here, write the slope down, write this point down, 2/3 and negative 2, 1. Then I'm going to leave this on the screen here so you can pause it. Do the same thing, but use the one that we just did. Pause it and try it, and then I will keep on going through the solution. So again, we're using y equals mx plus b. We know that m is 2/3. We know that x is -2 and y is 1, but I don't know what b is. So I'm going to remind you again what I just did. I know m is positive 2/3. I know that the x value is -2 from the point. And I know that the y value is 1 from the point. And then I'm going to use that to find my b. So I'm going to take out my calculator here because I'm going to probably need it for 2/3 times -2. So let's take a look at that. 2/3 in our parentheses there times -2. Press enter. It's kind of ugly decimal. Press math, enter, enter. It changes it back to a fraction of -4/3. And so -4/3 is right there. And then I want to move this 4/3 over here. Remember, when you move something from one side to the other, you have to use addition or subtraction, not multiplication. So I add 4/3 over here to get b by itself. So 1 plus 4/3. So I go to my calculator and I do 1 plus 4/3, press enter, and then I do math, enter, enter. That is 7/3. 7/3. So there's my b value. So now I know what my b value is. So my m is 2/3. My b is 7/3. So my equation would be y equals 2/3 x plus 7/3. And remember, one of the main reasons that we find these equations is so when we are looking at a real life situation that is modeled by this linear possibility here, this problem, you have the beginning amount and you have the moving amount, the m and the b. Something that does that in real life, we can then use that equation to make predictions about what may happen in the future. We have to be careful because we have to say what may happen because we don't know for sure if there's an exact equation that fits every single life situation. And real life can sometimes be unpredictable, as we are definitely living it out, unpredictability of real life. So let's take a look at a couple of real life examples that do this. I have this example here that says between 1985 and 1995, the number of vacation trips in the United States taken by United States residents increased by about 26 million per year. In 1993, United States residents went on 740 million vacation trips within the U.S. Write a linear equation that should, in your head, already start making you think, oh, well, write a linear equation. Okay, that's that whole mx plus b thing that we've been doing over and over and over again. I need to find m and I need to find b. So I need to see if I can find m and I can find b in this problem. So we want to write a linear equation that models the number of vacation trips y in millions. So my trips are millions of vacation trips, my, in terms of the year t. Now, we're going to use x instead of t, but you can use t if you want to. Also notice there's one little tricky sentence here that you really need to pay attention to. It says, let t be the number of years since 1985. That tells me that the beginning year is 1985. So the beginning amount that I'm looking for should be in that year. Here's the problem. Go back up to the whole two sentences up above and the statements of what's happening. It says the residents are going on an increase of about 26 million people or trips per year. 26 million per year. Increasing 26 million per year. It's going up by 26 million per year. It's going up 26 million per year. Did I say that enough times? I think I did. I hope so. This is my clue here. Increased by 26 million per year. That is my m. That is how the number of trips is moving across the graph. 26 million trips per year. So every year, it's going up by 26 million. Here's the tricky part. In the next sentence, you can really mess yourself up if you're not careful and think it's the beginning amount if you don't pay attention to that little sentence down there in part A. It says in 1993, United States residents went on 740 million vacation trips. That's in 1993. That's not the beginning year. Remember, the beginning year was 1985. 1993 is 8 years later. It's not the beginning. So that is actually a point, just like we had on these other problems back over here where we had the M and a point. And a point. So if we have how quickly something is changing per year, and we have a certain amount that's not the beginning year, but it's later down the road, we have a slope and a point. We don't have the beginning amount because the beginning amount's in 1985. So what we can do, though, is now at this point, we can find the equation for this line exactly like we did before. Meaning we can do our y equals mx plus b, plug in our m, plug in our x value and our y value from our point, and find the b. So I'm going to let you try that. Pause the video here and try it before you watch the solution. So the m is 26. The x value was 8, but we don't know what b is. The y value is 740 million. Now, I didn't mention this a minute ago, but let me mention it here. How do I know that the 8 is the number of years? Remember, 85 to 93 was 8 years. 740 million vacation trips is the y value because the trips right here are the y values. The years are the t or the x values. Now, you could, like I said, use t instead of x if you want to. So then what we do is we take this and we do 26 times 8. So we take out our handy-dandy calculator and we do 26 times 8. That's going to be 208. So this is 740 equals 208 plus b. Well, what would b be? Well, we take and we subtract 208. Subtract 208. And that's going to give me a b value of 532. Again, if you need your calculator, you can take 740 minus 208. Press enter, and it tells you 532. And what does that mean? That means my equation would be y equals 26x plus 532. mx plus b. I've found my b, I've found my m, I've got my equation. What does it mean realistically in real life, though? In real life, it means the number of trips is going up 26 million per year, and it started at 532 million in 1985. Remember, the 740 million is 1993, not 1985. So that's why this right here is the beginning amount. It's the actual number in 1985. Now, I definitely will have somebody in the class probably who will ask me, Mr. Harrison, if I know it's going 26 million a year, and I multiply that by 8 years, and then I subtract that from 740 to get 532 without writing all this crap in the middle right here, is that okay? Yes, as long as you actually write your equation for your line here. If you know that it's 8 years, 26 million a year, so you do 8 times 26 and you subtract that from 740, that's what I did anyways, guys. I did 8 times 26 and I subtracted it from 740. I'm just giving you a way that you can do it every single time whenever you have a point and a slope. A point and a slope. A point and a slope. You can do it the same way every time, and it does give yourself a routine so you don't mess up quite as bad. So part B. Estimate the number of vacation trips in the year 2005. Well, 2005 is not 93, it's not 95, it's not 85, so what do? How do I find the number of trips in that year? You still have to remember that T, or time, is the number of years since 1985. 1985 is the beginning, so 2005, I would actually plug in 20. So I go to my equation, and this is the whole reason for being able to find an equation. I plug in 20 for x, and then I use my calculator to find my y value, the number of trips. So I do 26 times 20 years, because it's 1985 to 2005, plus 532. Press enter, and it tells me 1,052. Now remember what that is, 1,052 million trips. And I know that's kind of weird to think about, but remember, 1,000 million is really a trillion. So that is kind of, a billion, excuse me. That is kind of weird to think about, but that is 1,052 million trips. And that's quite a few. But one thing to think about here too, as we look at this 20 years down the road that we're using this equation, remember, you got to be careful. Like I said, it can be used to make predictions, but you do have to be a little careful because it says between 85 and 95, the trips were increasing this much per year, 26 million a year. That doesn't really mean that it's going to keep doing that to 2005. So this estimation, this prediction, might actually be a little bit off from what really happened in real life, because this equation was really only good for a limited amount of time. And think about this. There's one particular event that would actually screw this number up big time, since 2005 happened after a very, very important event in our country's history. In 2001, 9/11, 2001, we had a major attack, and there was a lot of vacation trips that went down after that because people were scared to get on planes for a while. So be careful when you make this prediction. Please always keep that in mind. And always be careful when you're reading something in the newspaper, or you're reading something on Twitter, you're reading something on Facebook, you're reading something online, anywhere. Some guy's got a blog and he says the whole world's coming to an end. Make sure that you're careful. Make sure that you actually read into what he's saying and read what he's predicting and how he's using those predictions and where he's getting those predictions. Even our own news stations, you need to be careful. You need to make sure you're paying attention to what they say. Mathematically, you've got to really watch the numbers. All right, so let's take a look at another example here. Christina has her savings in a bank account. She withdraws $8.25 from her per week, from her account. After 10 weeks, the balance is $534. Write an equation that models the balance y of Christina's account in terms of the number of weeks x. Do not consider any interest earned by the account. First of all, I do want to point out this little phrase right here, in terms of. That's important because notice that the balance of her account y and the weeks x comes before and after that little phrase. The reason I point that out is because a lot of times that'll help you figure out what your y is and what your x is in the problem. If you see this little phrase, in terms of, even if it didn't have the letter y right here or the letter x, balance in terms of the number of weeks typically is going to mean that balance is y and weeks is x. So that's just a helpful little hint. So just like before, I'm writing my equation of my line that models the balance in Christina's account, y, in terms of the number of weeks, x. So I'm looking for my m, I'm looking for my b. So see if you can find m and b. Pause the video. Hopefully you realized that you could not find b. We don't know the beginning amount in Christina's bank account. We know after 10 weeks what she has. But we do know that she's withdrawing $8.25 per week. Keyword there, per, and withdrawing tells me that it is negative 8.25 That is how her bank account balance is moving down. So it's moving at negative 825 per week. So there's my M. But again, I don't have my B. I have another point, just like we had here, just like we had here, just like we had here. We have the slope, and we have another point on the graph. We have, after 10 weeks for X, the balance is 534 for Y. Remember, balance is Y, weeks is X. Here's another little helpful hint. If you know what the slope is, the M, you can also figure out what Y and X is, because it's dollars per week. Remember, slope is change in Y over change in X. So my Y's would be my dollars, and my weeks would be my X. That's another way to figure out X and Y if it's not given to you in the problem. So now we have M, and now we have a point. And so what we can do is the same thing that we've done several times already. Use Y equals mx plus b, and we can find my b by plugging in m, plugging in x, and plugging in y from the point. So go ahead and try that if you haven't already. So my y value is 534. My m is negative 8.25. My x is 10. And then I can use this to find b, because I don't know what b is. So I multiply negative 8.25 times 10. That would be negative 8250. If you think about it mathematically, and you think about real world, 10 weeks of withdrawing $8.25 would be $82.50 that you have taken away from your bank account. But here's where you got to be careful, because 10 weeks is 534. If I've taken that away, to find my beginning amount, I'm going to add 8250 back to this, because I've taken that money out. I've withdrawn that money. So my beginning amount should actually be a bigger number than what I have at 10 weeks. And I don't know why I put 32. 8250. Added back to the 534 is 616.5. or 616.50 if you think about it in terms of money. So the balance in Christina's account, the Y value, is equal to negative 8.25 or $8.25 per week, so times X, plus the original amount that she would have had would be 616.50. So now we can use this equation to figure out the amount that she has after any certain number of weeks. We could also figure out, okay, how long before she has $30 left. We could actually plug in $30 for Y and find the number of weeks, X, by solving that equation and figuring out how many weeks it would take her to get to $30. So it would give us a good idea of how much time she can keep doing that. She can keep taking out that money. Obviously, that's not what you want to do in real life. You want to be able to put money back in eventually, right? In a true bank account. So the next thing that we're going to look at now is, what do we do if we have not been given the slope either? We've been given, up until this point in this chapter, what we've done is we've been writing equations of lines where we were given the slope or the rate of change. We were given the y-intercept and we plugged them in. Then we looked at some where we were given the slope, given the rate of change, and not given the y-intercept, but given another random point. What do we do now when we get to an equation, a problem that looks like this, where it says write an equation of the line that passes through the points 1, 6, and 3, negative 4. Notice on this particular problem, we are not given M and we are not given B. We don't have the slope given to us. We don't have the y-intercept because neither one of these points has 0 for the x value. So if we don't have the slope, we don't have the y-intercept, that means we have to find both of them. What if I told you, though, that you already have those skills? We already found the slope earlier in this linear chapter. How do you find the slope? y2 minus y1 over x2 minus x1. Notice on this one you have 2 points, just like we had when we were looking at those particular problems finding the slope earlier in the chapter. It's the same concept. The only difference is now I'm not just stopping at the slope, but I'm also going to find the whole equation for the line, not just the slope. But finding the slope is still the same. -4 minus 6. -4 minus 6. y2 minus y1. So that'd be -10. 3 minus 1. 3 minus 1. x2 minus x1. 3 minus 1 is 2. And then I do -10 divided by 2. That's -5. There is my m. So now I have my m, but I still don't have my b. But guess what? Now we can just go back to what we've been doing all throughout this lesson. I have my m, and I have a point. Look at what you got in this one. I have my m, and I've got 2 points that I can choose from. So what I'm going to do is I'm going to show you how both of those give me the exact same answer. So if you want to, you can try both of them. You don't have to. I'm not going to require you to. But I'm going to use my y equals mx plus b, and I'm going to use my m, and I'm going to use the point 1,6 on this side. And then on the other side, I'm going to use the point 3, -4 and my m, because the slope is the same no matter what. The slope is the slope between those 2 points. But I'm going to show you that either one of those points can be used with the slope to find the equation of the line. So you may want to pause the video here if you want to try it on your own. You can pick either point. It doesn't matter. You can do both of them if you want to. It'll give you extra practice if you do. So right here, the y value, I'm going to plug in as 6. My m, my slope, is -5. My x value is 1, but I don't know what b is. So I'm plugging in 1,6, and I'm finding my b value. So what is -5 times 1? Well, that's -5. How do I get -5 over here? Well, I add 5. So what is 6 plus 5? That is 11. That's my b. So my m is -5, so it's -5x. My b is 11, so plus 11. There's my equation of my line. Well, what I'm going to show you is that if you decided to use 3, -4, because it's on the same line, and you know the slope is -5, you can use -4 for y, -5 for my slope, 3 for x, and I'm still going to end up with the same answer. Because what is -5 times 3? Well, that's -15. How do I get -15 to the other side? I add 15. I add 15. And that gives me 11. So either way, my answer is still going to be the same equation. As long as you use either one of those points and you use the slope that you have, you can do the same thing that we did over here when we had the slope and the point. The slope and the point. The slope and the point. It's the same concept. The only difference now is I actually had to find the slope first before I could find my b value. So I'm going to give you one to try on your own. I want you to pause it. And by the way, here's the concept in step format. If you want to copy these steps down, you don't have to do that. Basically, what this set of steps tells me is the same thing that I've been talking about the whole time. I need to find the slope. I need to find the y-intercept. And that will give me the equation of the line. But sometimes finding the slope and finding the y-intercept requires a little bit more work than just reading the problem. So I'm going to give you one to try. Then we're going to do a word problem with one of these. And I'm going to come back, I want to talk about this word too here in just a little bit, perpendicular. But I want you to find the equation of the line for line AB. So from here down to here, I want you to find this equation of this line right here. So pause the video and try that real quick. So the slope, using these 2 points, if I do y2 minus y1 over x2 minus x1. So again, I'm going to say that again. y2 is -3 minus y1 is 1 over x2, which is -4, minus x1, which is -6. -3 minus 1 is -4. -4 plus 6 right there, because minus a negative becomes plus a positive. So that's -4 plus 6, which is 2. -4 divided by 2 is -2. Now look at your line. It's going down 2 over 1, down 2 over 1. That's what the slope is. So that's my slope. Now I need to find my b. Remember, this is where we had to do a little bit of work now, because that equation is going to go down here. My b value is going to be down here somewhere, all right? So I have to use my little mx plus b, plug in my y value from one of these points. Doesn't matter which one. I'm going to go with the 1 up here. And then I'm going to use my x value of -6. My m that I found was -2. So I'm going to show you what I did again. My m, my slope, is -2. My x value is -6 from the point. My y value is 1 from the point. And then I take and I find my b value by first multiplying. -2 times -6 is 12. Then subtracting 12 from both sides. 1 minus 12 would be -11. So that is my b value, -11. So what would the equation of that line be? Y equals -2x minus 11. And if you look at that, it should make sense. It's going down 2 over 1, 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 down 2 over 1. It's going to hit way down here at -11 eventually if you extended that line. But this will be the equation. Now remember, we talked about earlier in the year, and I'm not going to do this too much onto you on the quiz or the test or anything, but remember we talked about earlier in the year, if you have stopping points on the ends of the line, that's that whole concept of telling somebody where to stop is called the domain, telling them where the x's start and stop. All right, so we got one more we're going to look at. This is an example from archaeology. It says, while working at an archaeological dig, you find an upper leg bone, which is called the femur, that belonged to an adult human male. The bone is 43 centimeters long. In humans, femur length is linearly related to height. Again, there's that word linear, right? To estimate the height of the person, you measure the femur and height of 2 complete adult male skeletons found at the same excavation. So let me kind of give you the concept of what you're doing here. You are finding these remains at this archaeological dig, and you find an upper leg bone of one particular human. You want to figure out how tall he is. So what you do is you use 2 other people at the same site to find an equation that you can use to figure out how tall he is. Now you could use these 2 other people to also kind of estimate, but what we're doing is we're given an equation, so we have a little bit better mathematical prediction. And so it gives you a legitimate thing that you can tell somebody. Other people who may use this, if you think about it, would be like crime scene investigators or doctors, things like that. When a crime scene investigator gets to a scene and there's only remains left, they can use that to help us figure out how tall somebody is, how much somebody weighed, We can look at their shoe pattern to figure out their walking, how far they're stepping on each step of their walk, or do they have a limp. There's all kinds of things that you can do, and it honestly all comes down to mathematics. I know you guys don't tend to believe me, but it does. So we use person number 1 and person number 2. We're going to find an equation using those two people. Notice that basically this one is perfectly set up here with my x and my x and my y, just like this one was. We had 2 points. Just like this one was over here, we had 2 points. So I'm going to find my equation of my line using these 2 points. So again, I'm going to find my slope. y2 minus y1 over x2 minus x1. 173 minus 162 is 11. 45 minus 40 is 5. So 11 over 5. Now, if you take 11 divided by 5 in your calculator, it's going to give you a decimal. But it's a pretty nice decimal. And so I'm okay on this problem if you use this for your slope or you use this for your slope. Either one is fine here because, think about this. 11/5 is probably more appropriate mathematically. It's a fraction, right? It's exact. But 2.2 doesn't have any weird decimals. I didn't cut off any decimals, so it's also exact. Here's the other reason that's okay to use 2.2. If you're thinking about centimeters in height per centimeter of a femur. Basically what that means is every centimeter of femur, you expect to gain 2.2 centimeters in height for that person. So let me say it another way. As your femur gets longer, each centimeter, the person gets 2.2 centimeters taller. So now we have our M, but we don't have our B. But again, we can use y equals mx plus b, and we can plug in our M, 2.2, plug in an x value from one of those points. I'm going to use 40. Plug in a y value from one of those points, 162, because that's the same point, 40, 162. And I can multiply 2.2 times 40. 2.2 times 40 gives me 88. Then I subtract 88. Subtract 88 to get my b value. So 162 minus 88. So I take 162 and I subtract 88. That gives me 74. 74 is my beginning amount. That's my b value. So now I know m and now I know b. So my equation would be y equals 2.2 times x plus 74. And what that means is if I can use this equation now, anytime I find a centimeter for somebody, a femur for somebody, I can measure it, put it here, and find out how tall they are, why. So this guy, I can take 43, plug it in here, and do 2.2 times 43 centimeters plus the 74 beginning amount, press enter, and that's how tall that guy is, 168.6 centimeters. Now, if you don't know, if you divide that by 2.54, there's 2.54 centimeters in each inch. So if you divide that by 2.54, you're going to end up with, oh goodness, come on calculator. You're going to end up with 66 inches. So basically 5'6" is how tall this guy is. So what that means is that this guy is relatively short. Does it mean that everybody at this place is short? No, it doesn't mean everybody at this place is short. But it could mean as a whole that this population is probably shorter, considering this guy 40, 162 is even shorter than that. So this gives me now the ability to make some, predictions about this population and make some observations. I can't say everything with 100% certainty. Like I said, I have to be careful there, but this is a good predictor of how tall that guy is. Also notice this 74 is kind of weird, the beginning amount. That means if you had 0 for the femur, you'd be 74 centimeters tall. Now that's kind of weird to think about it if somebody doesn't have an upper leg bone. That would be kind of weird. But that's what that beginning amount means. That's why you have to be careful. With the real world equations, they're not always going to be perfect. But they do give me an ability here to make predictions. All right, so the last thing I just wanted to go back over here and remind you about, and I'll be done, is don't forget this little word perpendicular, what that means. We talked about parallel earlier. Perpendicular means two lines that meet at a right angle. But for something to be perpendicular, the slopes have to be opposite and reciprocal, meaning they have to be flipped and they have to be opposite. Instead of negative, it would be positive. -7/4 would be the opposite and reciprocal of 4/7. +1/9 would be the reciprocal of -9/1. So be careful with that. If you see any of that in some of your homework, when we're talking about perpendicular, it means the slopes are opposite and reciprocal, because one line would be going down, one line would be going up, and they meet at a perfect right angle. You'll learn a little bit more about that when you get into geometry, but I didn't want you to panic when you see that word later on. So for your homework today, you will find it, if you go to your Schoology page, you will find it underneath this folder, Quarter 4, Writing Linear Equations Given Point and Slope, or Given 2 Points. I'm also going to upload this video there. It may take a while for me to get everything uploaded here, but you'll be able to click on this, just like you did your previous one. You'll be able to click on the homework, and then you'll be able to click on the assignment and turn it in. If you don't remember how to do that, you click on the assignment and you hit the submit thing. You can submit a picture, it's completely fine, of your work. In fact, I'd kind of like to see your work. That will make me believe that you actually tried it and did it very well. But it is an easy grade if you just turn in your homework. Now, make sure that you realize also too, later this week, you are going to have a quiz on Schoology where you enter in your answers to the problems using Schoology. You're going to enter in your answers to these types of problems of writing linear equations. That quiz will be coming up later this week. So, if you got any questions, I'll be on WebEx several times throughout this week. And so we can get that. We can do several little lessons together and do some practice together if you have any questions. So I hope you guys do well.